from Kyiv. I'd like to thank our organizers and hosts and all participants for their efforts to organize this conference. Our focus of our presentation is on digitalization of critical infrastructures and corresponding security issues, and moreover on cascading effects of power outages. We prepared our presentation focusing on another workshop about sustainable and resilient energy sector. But the organization committee decided another way. No problem. The main idea of our presentation is to show an approach for the assessment of digital resilience of critical infrastructure and its interdependencies with power energy sector. Widely known that a definition of resilience, including digital resilience, depends on context. Nevertheless, in any context, digital resilience evidently depends on secure infrastructures which are necessary for delivery of essential services. It depends on the presence of digitally skilled individuals also who can take actions to counter, absorb, and recover from incidents. In the context of Russia's full-scale war against Ukraine, one of the key aspects of recovering Ukraine's energy infrastructure is ensuring the resilience of information and communication systems of energy sector. Given the global context, a Ukrainian future electricity system will be a distributed, decentralized system consisting of a variety of energy sources: thermal, solar, wind, large and small nuclear generation, as well as new modern control systems for these distributed power grids. However, the coordination of multiple distributed facilities requires complex and complicated control systems that are targets for cyber attacks. In addition, the connection of distributed systems to the national grid further increases the attack surface. To better understand, analyze, and protect those systems, we require an approach to identify vulnerabilities and develop appropriate protection strategies. The first step is usually decomposition. Decomposition means breaking those objects into smaller components in order to determine the internal interaction between the components. The law of Ukraine on the basic principles of cybersecurity of Ukraine defines a critical information infrastructure object as communication or technological system of a critical infrastructure facility, a cyber attack on which would directly affect the sustainable operation of such critical infrastructure facility. So it's a system based on electronic communication that can be subject of cyber attack. This means that the concept of critical information infrastructure object implies a connection between this system and cyberspace. The term cyberspace also defined in the law. According to the definition, the existence of shared or interconnected communication systems defines cyberspace, and it creates preconditions for cyber attacks. The definition of cyber attacks is also provided in the law, and for the purpose of this study, it can be narrowed down to implementation of information security threats using cyberspace. In order to determine the functional components of critical information infrastructure, we propose following decomposition, which describes the components of information infrastructure in context of interaction with cyberspace. We'd like to introduce a critical information asset, CIA, This is a central component of critical information infrastructure. The violation of its integrity or failure to provide authorized access to it will directly affect the sustainable functioning of critical infrastructure facility. And the next, critical information asset access tools. Access tools is a set of communication or technological systems that provide access to the critical information asset. Once the object of access is defined, the subject of access also should be defined. Um, as information asset can be a cyber system that performs digital services for the benefit of users who receive the service through the cyberspace or simply through the internet. In this case, users of such system are referred as subjects of access. Also, critical information object can be managed by administrators, system administrators, through the internet, for example, using VPN technologies. And such administrators are also subjects of access to the critical information asset. Thus, we have identified three subsets of elements that are united by the concept of critical information infrastructure. We can state that combination of critical information asset tools, and a subject of access tools and subject of access form something described as a virtual space that provides opportunities for communication, and it's formed as a result of the functioning of interconnected communication systems and electronic communications using the internet. This corresponds to the definition of cyberspace. At the same time, critical information asset and subject of access obviously become the object and subject of these communications in cyberspace. And access tools are provided by electronic communications. It is a modern term for telecommunications. Based on the above, it is proposed to define the concept of critical information infrastructure object cyberspace. It is a subset of cyberspace elements formed as a result of the functioning of access tools to critical information asset owned by critical information infrastructure object, connected to cyberspace and providing access to critical information asset to the subject of such access. CSCIIO means the cyberspace of particular critical information object. If we call all these elements of cyberspace as points, and if we call all these combinations of CIA, AT, CR, SACR as topologies, we can see that cyberspace seems to be a topological space, specifically a discrete topological space. In set theory, topologies allow to study continuity, connectivity, compactness, isomorphism, and other characteristics. But it's for future studies. And now we proceed to our decomposition, to our decomposed cyberspace of critical information asset. Access tools is a set of communication or technological systems that provide access to critical asset. It can be considered as a supply chain that inherently exposes to risks rising from well-known threats. The accuracy of risk assessment depends in particular on the degree of detail of the physical and logical topology of electronic communications. Widely recognized NIST framework for improving critical infrastructure, or shortly NIST CSF, describes the components of the risk identification process, in a particular risk assessment, which consists of several activities. And we can see that activities in category 10 requires a supply chain analysis. Then another NIST Guide to Operation Technology Security. Those recommendations, they recommend a risk management framework. And at the very first step on it is to classify information systems according to the potential impact of loss. For each type of information and each type of information system, there are three security objectives: confidentiality, integrity, and availability. They are associated with one of the three levels of potential impact that would be caused by security breach. Ukrainian regulatory documents currently do not contain specific guidance on categorization of information security risks. However, in accordance with methodology proposed in NIST, the last NIST document, operation technologies should assess the threats against the effect of information security objectives: confidentiality, integrity, and availability. In this way, each link in the topology of external links for critical information infrastructure object in cyberspace can be categorized. Categorization is necessary because different security controls are applied to ensure availability and confidentiality. Many factors can be taken into account for categorization. The main one being the category of information assessed via this link. As an example, for sensor information, the availability requirements will have the highest priority. For firmware upgrades, however, the highest priority will be given to data integrity. As example of initial information for risk analysis of a particular external relationship, we propose category of subject of access, categories of information he or she operates, the level of security of protocols used for this access, and criticality of information availability. Or in other words, acceptable downtime. It is also possible to use template options to categorize impact using weighting factors according to the role of particular subject of access. The result of categorization by impact on confidentiality, integrity, and availability, and the weight factor of the respective subject of access determines the assessment of losses impact. That's how we use weighting factor to assess losses. So from this moment, connections of subject of access in cyberspace are involved in analysis of cyber risks of critical infrastructure facility. The disadvantage of this method, and the subject of future discussion, is the need to determine the degree of influence of subjective expert assessments in the assignment of weighting factors. Let's try to implement our methods. I'll be short. During the war Russian war against Ukraine, the aggressor attacked civilian energy infrastructure, causing all we know about blackouts and all we know what it is expected by us in future winter. So each critical information asset must be protected, to be more resilient. There are some strategies for each information system: to host them in premises, to host them in clouds, to host them in dedicated data centers, but using own physical infrastructure. And each of those aspects can limited applicability depending on critical information asset. Many of critical assets are not transferable to data centers. Let's look on in-premise deployment. It always poses additional risk of ensuring the safe functioning of critical assets. And if we look future on subject of access, there are some strategies to develop their resilience. It is in-premise power supplement, usage of technologies, telecommunication technologies, which are more resilient to power outages, and to have the personnel with particular digital skills required to continue their operations in cases of blackout. We made pretty deep analysis of such factors, and we found that effectiveness of implementation can be reflected in the reduction of the recovery time and in the reduction of cost of recovery within the specified time, also known as recovery point objective, or RPO, under the conditions of compliance with assessment of losses. Example: passive optical network technologies are considered to be most resilient to power shortages if the end user provides autonomous power supply for endpoints. So this is a technology to power is resilient to power shortages, and it reduces the recovery cost in the event of blackout. In critical infrastructure, business continuity, or in other words, faster recovery, is the highest priority. The effectiveness of proposed method is the method of assessing digital resilience should be measured in order to obtain a quantifiable or semi-quantifiable assessment of the chosen solution. So the conclusion, our results and future discussion. We should aim to minimize the influence of subjective expert assessments in the assignment of weighting factors and metrics. And a strategic direction, we dream to provide a mathematical formulation of the resilient system. Thank you for attention. Please, your questions.
Yeah, thank you very much for your presentation. We have a very tight schedule, so maybe one short question. Have an option. There is no. If there is no questions, one question from my side. Do you have some kind of practical experience to use your approach during the design of, for example, real information system from the scratch, for example?
Not yet. However, we collected all the information of the winter of 2022, 2023, and other information from this spring and this summer from owners of critical information assets and providers of communications. How do they fight blackout consequences? And how do they optimize their infrastructures and so on?
Thank you. Thank you for answer. So the next talk, as proposed, Natalia, will be done by Dmytro Chumachenko. He is from our morning session, as I understand. Yeah.
Afternoon.
Afternoon. Yeah. So, Dmytro, you can start.
Yes. Hello. Thank you.